I can't hear you.
Can you hear me now?
Yeah,
Good.
I guess.
Okay.
When you're doing these, you're supposed to write down a -7, +7, or the like the 0 and -0 or something.
You'll understand it better when I do the next one.
Okay.
And Isabel,
Uh-huh.
working on packet 3, page
Packet 3.
1, and
Okay.
I'm doing a number 1 on that page.
Okay.
All right. So what we're going to do is ignore this, and our steps for this page, are going to be solve the equation for y first. Yes? Then plug in. So we've solved for y. We're going to start plugging in. And Isabel, some of the students here took a picture of the first page, and they can text it to you here in a little bit.
Okay.
All right. Okay, this is the same equation we're going to use over and over again. Did y'all text that front page to Vanessa? Okay, now the next x, here is the x value right here, 1. So they said now use the same equation but put 1 in for x. So we're going to say y equals 7 times 1 now minus 7. So y equals 7 minus 7. So y in this case equals 0. It says if you plug in 1, you will get an answer of 0. So we plugged in 1 and we got the answer of 0. You'll see how this is going to work? Now we're changing the x value to a 2. I'm only erasing. Y'all will have these underneath each other working over and over again. Y equals 7 times 2 now, because it says the x value is 2 minus 7.
So it would be 7 times 2 is 14.
14.
And -7. And then y, 14 take away, yeah.
14 take away 7 is 7. So now if you plug in a 2 for x, you'll get y equals 7.
Okay, so it's kind of like just doing the multiplication table.
Over and over and over again. Yes, ma'am.
Yeah.
It goes by whatever the x values are. In the first page, they gave you the x values. So our next x value, we've got to plug in a 3. So y equals 21 minus 7. So y equals 14.
Okay, I think it's not.
Getting it? And we're going to do it one more time for 4. Okay. There was a 3 there.
Yes, there's 4. There's 4 in it.
The thing I don't get is putting dots where they need to go to have the answers.
We'll figure it out. I'll give you one page at a time. Okay? Did you get it? Okay. Okay, so y equals 14. Y equals 14. What I'm doing here, Vanessa, is I'm showing that the vertical t-chart and the horizontal t-chart are the same. I prefer this one, but you will probably see that one on the test also. I don't know which one they'll show you. So I'm wanting you to know that both of them are the same. Now, one more time, we need to do this, where x equals 4. So we plug in 4. 7 times 4 is 28 now. 28 minus 7 is 21. So if x is 4, then y is 21. Y'all see? Now that we have finished the t-chart, the rest of it's pretty easy, because remember, our x and our y are the coordinates in a point. So this creates a point on our graph. You go find this point, you go find this point, this point, this point, and this point. Now we know that it's going to make a straight line because I told you earlier, we didn't stay on it for very long, but I told you earlier that if it has an x and a y in the equation, and there's no exponent larger than the invisible ones, then it will create a straight line. So as we plot these points on the coordinate graph, if it doesn't create a straight line, then you need to go back and figure out your math because there's a mistake somewhere. Okay, let's plot these. Okay. The first one, we have 0 and -7. So we go 0 places on the x-axis. This is the x. This is the y. Okay, so we go 0 on the x-axis and -7 on the y-axis. So here's our first point, 0, -7. Y'all see?
You went down from the.
Yes, because I always started the origin to plot a point,
Mhm.
and it says to go 0 spaces on the x-axis, and then you go up and down the -7. So we went down -7. The next point is 1, 0. So we go 1 on the x-axis and nothing up and down. So there's our point there. Okay, we need another point, 2, 7. So we go 2 and 7. So here's our point. 3 and 14. Here's the 3. And I go up to the 14 right here. And one more. I think we have enough room. 4 and 21. 4 and 21. Now, if you will notice,
Some don't have the numbers.
say again.
Some don't have the numbers you're saying.
Your graph probably doesn't have 20 on it. And then if you line these up and draw a line, you can see that these points are what we call collinear. That means that they're on the same line, which is what we need. Because it's a linear equation, it will create a straight line. Y'all see it? Now, if you happen to, as you went through and you were graphing, and this happened, this one was okay, this one was okay, this one's over here, this one's okay, and this one's okay, then you can see probably this is the line you need to go back and check, number 1, whether you did your multiplication right, or number 2, maybe you just plotted it wrong, okay? But you know this one's the weirdo, so these are probably right, you need to check that one, okay? Because linear equations will make a straight line. Are we good?
Yeah.
Yes. Do I need to do another one?
Yes.
Okay. Let's do, I'm going to make up one. Okay, now on the second page, you get to make up your own x's. So when there's a T-chart, sometimes, like on the test, they may give you the x values. They may give you a blank one, like the second page of your packet 3. Do you see? Turn the page and you can see that the whole T-chart is blank, which is not a problem. When if they give you a blank, That means you get to choose any value you want to for your x. Now, as I went through school, my teachers explained to me that it's probably best to keep the numbers relatively small, to make sure that you have some negatives when you put numbers in here, positives, and definitely put 0 in here. So tell me what the first equation is on that second page.
3x, subtract y equals 9.
Equals 9. Okay? So I think we're going to solve for y first, and then I'll put values in here, okay? So we found out the easiest way, although you could plug your x's in right now, the easiest way is to solve for y. So if we want to solve for y again, this is good practice from yesterday, then we can see that we have to get rid of the negative, and we also have to get rid of that whole thing, 3x. We don't want to separate the 3 and the x and leave part of it here. We want the whole thing gone. So this is a positive 3x. If it doesn't have a sign, it's positive. And this, so to get rid of the whole thing, I have to subtract it. To balance the equation, I have to put it on the other side. And notice again, I gave them separate spots because we have an x number and we have a plain number. We don't want to combine those. So now I have a negative y equals, and I like to put my x first. Just remember that you bring the sign with it. So negative 3x, and this is a positive, so it's plus 9. Now it looks almost solved, but we still have this negative to deal with. We know that if there's a negative there and no number, that it's the invisible 1. We need to get rid of the invisible 1. So yes, we're going to divide by negative 1, which means I have to divide this whole side by negative 1. Now I told my students yesterday, a lot of the teachers say divide the whole side by negative 1. I found out that it's easier for each student because we will be dividing everything by a negative 1, so we do it separately. Okay, the negatives cancel out to positives. The 1 divided by 1 is 1y. The 2 negatives cancel each other out, so I have 3x. And then a negative and a positive make a negative, so I've got minus 9. So this is the equation we're going to plug into because it's just easier. Okay? So now we're going to decide on our numbers. I'm going to give you the numbers that I used all the way through high school, all the way through college, and they work. Okay? Remember that the suggestion is that you always use a 0, you always use some negatives, you always choose some positives, and you keep the values low. We don't want to put 117 in here and try to deal with that. You just don't have that many spaces anyway. So the numbers that I used in college were -2, -1, those are my negatives, and then 0, and then my positives. That's what I chose. Now there will be times when you'll still do negatives and 0 and positives, but you might use multiples of 3. I'll just tell you when we get there. Okay, it's easier than explaining it now. Okay, so what we're going to do here, see, anytime that the x's are blank, you just choose, because it doesn't matter what number you choose, it will be on the line. It will work. You could choose 2/3, and if you worked the equation correctly, it'll be on the line. Okay, so it doesn't matter. This bothered me when I first saw it, and I thought, yeah, but I want to choose the right numbers. There's not right numbers for x. Choose anything you want. You can choose 117 if you want, but I'm telling you. Okay, so the first one has to be a -2, y equals 3, and in place of x, remember when you substitute, use parentheses. always when you substitute a value. So this is what it's going to look like for the -2. It says if x is -2, I want to find the answer for y. So I put this in here. I have 3 times a -2 is -6, y equals -9. And then you'll have to go back to your rules for negatives, adding and subtracting negatives, and y will equal a -15. -15 for y. Now we're going to put in, oh, do you have this, Irene?
Yeah. On that X and Y, how come we can't just do 0, 1, 2, 3, 4 like the first one?
You can.
You can?
Yes, yes, you can. Later on, the reason I always tell you to get negatives and positives, later on when we start doing what Irene was talking about, these values, sometimes you will need the negatives to be able to complete that graph. But yes, you can use the 1, 2, 3, 0, 1, 2, 3, or whatever. Any number you want. You do not have to use my numbers. So the next one says, let's put a -1 in. So -1, -3 minus 9, y equals a -12 this time. That's if I plug in a -1, I will get the answer -12. You'll see? Okay. All of the work is not being seen. Sorry, guys. And now, same equation, we're going to plug in 0. If we plug in 0, we're going to have y equals 0 minus 9.
It's gonna be 0.
Are you sure?
Let me see. It's gonna be a -0.
-9,
Not,
because you're just adding, you're not multiplying.
oh, okay.
If you multiply, you get the 0,
Yeah,
okay? So -9, we have 2 more.
Oh, negative.
We plug in a 1 now because it says, what if x is 1? What will y be if I plug in 1? So now I have y equals 3 minus 9. So y equals a -6. And looking at the pattern, what do you think it'll be? I like to guess.
-3.
Negative what?
3.
Yes. Let's put our guess right here and then let's work it. So it says that we need to plug in 2 for x. So where x was, we're going to put a 2. Now I have 3 times 2 is 6 minus 9. So y equals a -3. Ta-da! -3 was correct.
And everything was negative.
Yeah, you'll have to work with your negatives or use a calculator. Okay? So let's graph this and see if it is indeed linear. We can look at the equation. We know for a fact it is. So it better be. All right. Want to graph it? Mm-hmm.
I can't even figure out how to do it on this blank
Having
one.
trouble
Do I
there?
put in the X, the lines in there?
Mm-hmm. There you go. Okay, so our first point is -2, -15. -2, -15 is right here. 0, -9. Oh, I forgot the -1, -12. Right here. 1, -6, and 2, -3. Straight line?
Yeah.
I think so. Let's see if it lines up. See if we have any strays. And sure enough, if you draw the line, it goes through every point. You'll see? Now, if you chose a positive 4, Rebecca, you were asking if you choose a different number. If you chose the 4, then it would be 4 and up here, maybe 3. Let's see. I've got to be exact. Yes, it would be 4, 1, 2, 3. 4, 3 is what would come out because it's on the same line. No matter what number you choose for X, it'll be on the same line. Yes? Sort of? It's brand new. I know. It's brand new. Now, the paper that you have maybe only has, it goes to +5, -5. Is that right? If you draw your X and Y axis, I'll let them see what I'm talking about. On the paper itself, this is the graph they give you. Okay, so if you draw, see, that gives you this blank. So if you draw your X and Y axis like she has, then you're only able to go up to +5, down to -5, positive and -5, but you have numbers that are larger. So you can choose to make each one of these squares be 2, 4, 6, 8, 10, or you can make each one of the squares count by 5, 5, 10, 15, 20, 25. Okay, you just need to mark it on your graph so you know how much you're counting by. Oh, I see some faces. Okay, we're going to work on it today. Do you get the gist of what I'm talking about?
Very little.
Where they'll give you an equation, they'll give you a t-chart. You solve the equation for y, we found out that's the easiest. Then we plug in each x to find the y value. Then we plot the points. Yes? Mary, are you okay? Do you have a gist of it until you try it? Then you'll ask questions. Okay, Irene, I know today is like, it's not a good day? Okay, well, you'll come up and let me help you?
Yes.
Okay. What about you, Isabel?
I got it.
Okay, so you kind of understand what we're doing? Make sure that you text me or
Yes, ma'am.
FaceTime me or anything if you need help figuring these out, okay?
Okay,
Okay.
okay.
So I'm going to give the whole class today to let you work on these, and some of you still need to work on yesterday's where we were solving for y, okay? But that's all we're going to do today because this is brand new. Now I'm going to wait till Monday to do the rest of the graphing the lines in packet 3, okay? Packet 3 has several different things, and I'm not going to cram them down your throat today. Remember that on Fridays now, we don't do a Zoom, so you're just going to use this time to finish your worksheets, ask questions. Remember, Isabel, you don't bother me. So just let me know if you, okay?
Okay.
Okay. I am finished for today. Are you guys okay with except asking questions?
Yeah.
Okay. All right, that's it for today.
Okay, well, I'll see you Monday.
Okay, see you Monday.
Have a blessed weekend.
You too. You know I love you, right?
I love you too. Thank you.